2017 question for part C.
B.
For B. Okay, so d squared h over dt squared. The idea is this is the second derivative. And we know this is because this guy here is my first derivative. And besides us squaring everything, which refers to our second derivative, that's just what they want us to do. So use the second derivative to determine whether the answer in part A is under or overestimation. Oh, okay. Of the internal temperature. Now, in part A, they asked us to write an equation for the tangent line. So y minus y1 equals mx minus x1. That's the idea. For the graph of h, this was the slope, and they gave us the point 0 and 91. Okay, y minus 91. Okay. Now use this equation to approximate the internal temperature at t is equal to 3. Okay, so a couple things you want to see when you're drawing a tangent line. Let's say it's concave down. If it's a tangent line going this way, it's going to be an overestimation. But also if it's a tangent line going this way, it's still an overestimation. So if it's concave down, we see the tangent line will always be an overestimation. It's always above that line. But if it's concave up, the tangent line will be under the line. So if it's under the line, that means it's going to be an underestimation, right? Meaning the tangent line is lower than the actual value. So in part B, it's asking me to use the second derivative to guess, is it concave up or concave down? Now, of course, when I was reading the problem, I didn't know that. I just was asking, like, what the hell do they want? And the big deal is that when I drew the graph of what the second derivative gives me, concave down and concave up, it kind of gave me a hint. And it gave me a picture that it would be an over or underestimation for the tangent line. So we take the second derivative of the problem. So d, let me rewrite it in another way. D or dt of dh over dt. If you're joining us, we're working on 4 part B. So we take the derivative of that, we end up with -1/4 is a constant. And then the derivative of h is h prime, and 27 is a constant, so just h prime. Did we figure out what h prime at 0 is? We did. So in the last problem, we should have found out what h of t at 0 was, because I'm going to end up plugging the value 0 here. So once I plug -1/4, and then h of t at 0, which is h of 0. And if this is positive, we know it's going up. If it's negative, we know it's going down. Let's see. If I plug in 0 here, we end up with a -27. So it's positive 27/4. That's the derivative. -1/4. And that's going to be a positive 27/4. So I see this is going to be the second derivative is okay, yeah, that's what we did. Negative, and this was going to be a positive or a negative value. H. Oh, dang it, I wasn't paying attention. This h value, I was thinking it was my variable t, because I was being stupid. This is my h value here, and that's 91. Okay, that's where I was like, what? So this part's wrong. I read it as t, but h. So h is 91 when, let me show you. This here, I should write it out. This here is dh over dt at 1/4 h of 0 minus 27. Okay? And then h of 0 is given to us. That's positive 91. 91 minus 27. That's going to be a positive number. I'll write the negative here. So that's going to be a negative 1 over 4, and then whatever this is, which is some positive number, 70, nope, sorry, 64? 64, yeah. Okay, and that's going to be negative. So once I plug this number here for the derivative at 0, this here would be a negative and a negative. Becomes a positive, which is greater than 0. That means we're concave up or down. Second derivative is positive, that's concave up. So we have this graph here. The tangent line would be an under approximation, whichever side we're at. Okay. Olivia, is that okay?
Yeah, that makes sense.
Okay. Do you want me to go over C?
No, I don't think I needed C.
Okay. Anyone else have any questions? Unless if Olivia has another one.
I have another one on a different question.
That's fine.
Number 5, same year.
Oh, number 5, whoops. Okay. I'm recording this, so if you guys missed the beginning of it, you guys can always watch the video a little bit later. Or if it's going too fast, hopefully it's not going too fast. But okay. Okay, 2 particles move along the x-axis between 0 and 8. The position of the particle at time t is given by this. Okay, so particle is moving, I guess, left and right based on some t. While the velocity of the particle q at time t is given, okay, they give us the velocity of a different particle where q is equal to x is 5. So x at 0 is equal to 5. Okay. So for A, between 0 and 8, when is the particle P moving to the left? So left, so if you think of velocity is taking me forward, then velocity negative is taking me backwards, okay? Because I'm losing space. A positive velocity means I'm gaining value. A negative velocity means I'm losing value, okay, or losing position. So how do we find that out? Well, we just take the derivative of position. Our derivative of position would give us velocity. So v would equal to x prime. In this case, p of t, and x prime would be 1 over t squared minus 2t plus 10, because the derivative of natural log is 1 over, multiplied by chain rule, which is 2t minus 2. Now, when will this value ever become negative? Well, let's check the top right now. If the top is, when does 2t minus 2 ever become 0? Okay, we're checking when this is 0. It's 0 when, let's see, 2t plus 2 to both sides. T is equal to, 2t is equal to 2, divided by 2. T is equal to 1. There's only one place where this becomes 0. Now, is that going to be a positive or negative? On what side of that? I can draw a little graph here. At t is equal to 1, we know the velocity is 0. So we plug a number on the right and to the left. So looking back at this equation here, if I plug a number that's a little bit bigger than 1, let's say 1.2, 1.1, this would be more positive on the right and negative on the left. So I'm seeing that this graph is moving to the left. Let's see, answer the question. When is the particle P moving to the left? It's between 0 and 1. Okay. That's the first question. Why? Is because the velocity is negative. So when v is less than 0, between 0 and 1, the particle is moving to the left. Okay. Now, part B, for all times t during which the two particles travel in the same direction. Okay, so whether we're going positive or negative, so we know for this one so far, for the first graph, where p at only one spot when x equals to 1 was a particle going to the left from 0 to 1. And then from 1 to 8, you were going to the right the rest of the time. For our second problem, q, let's see, when does t squared minus 8t plus 15 equal to 0? This problem is factorable. Two numbers that multiply to 15, 5 and 3, and they do add up to 8, so this is factorable. T, 5, 3, negative, negative. So this is 0 when t is equal to 5 and t is equal to 3. So drawing my line over here, we know it's 0 and 8. Now 3 is going to be a little bit over here, and 5 is going to be over here. So we're going to see at what values would this velocity be positive or negative. So we want them to go in the same direction. So if I plug in two large numbers, let's say something bigger than 5, so 6 and 6, that would make both these factors become positive, right? 6 minus 5, 6 minus 3, they would both be positive. So we're positive over here. If I pick a number between 3 and 5, let's say 4, the second factor would be positive, but the first factor would be negative. So we're going to be negative here. And if I plug in a number between 0 and 3, let's say 2, they would both be negative. So this would be positive again. So in what intervals were the particles going in the same direction? Well, at 1 to 3, they were both positive. So t between 1 and 3, they're both moving to the right. And then from 5 to 8, they're positive again. So from 5 to 8 is also moving to the right.
Do we have to put the equal sign underneath since it's closed? Like when you're doing 1 to t to 3, do we have to do 1 less than and equal to t less than equal to 3?
I don't think that they'll burn you for that.
They won't care.
I don't think that they'll burn you for that. But if you catch it, that's good. But I don't think they'll burn you for that.
Okay.
But you're right. Like the right side, it's still positive.
The thing it's closed. So I was
still
like,
positive.
yeah.
Yeah. Okay, any questions on this part? Okay. Part C. Find the acceleration of the particle q at time is equal to 2. So we know acceleration is the second derivative of position or the first derivative of velocity. So they gave us the velocity and we want to find the acceleration of q. Let's go and take the derivative. So a is equal to v prime of q of t, which is 2t minus 8. And they want us to specifically find a at 2, the acceleration at 2. So we're just going to plug in 2 there. 2 minus 8, 4 minus 8 is negative 4. So what does an acceleration of negative 4 mean? It means, are we speeding up or slowing down? Imagine if the wind is fighting you, right? It's giving you a negative acceleration, it is slowing you down, okay? So we're moving not as fast to the right, we're slowing down. Is the speed of the particle q increasing or decreasing, or neither when t is equal to 2? Now, this kind of takes us back to what we had drawn over here. So looking at q, erase some of these marks here. Oops. So we already drew out q, which was the second graph here. Now, when a particle is speeding up, it means both the velocity and acceleration are both the same sign. And that was a big deal before. We said if you are running forward and the wind is blowing at your back, so both velocity and acceleration are in the same direction, that means you're going to be speeding up. Think about you running on the track field. When the wind's blowing at your back, it makes you run a little faster. But when the wind is blowing against you, it's fighting you, it slows you down. So the question is at 2, let's, oh darn it, let's see where 2 is. 2, we said the acceleration would be negative here at 2. The velocity at 2, we can just plug that in also. V at 2 is equal to 4 minus 16 plus 15. This turns out to be 19 minus 3 is 19 minus 16 is 3. And our graph here shows that was going to be positive, right? Positive. So since the signs are different, one is positive, one is negative, we are decreasing. The speed of the particle is decreasing. This is different than when we use the word speed in general. Speed refers to, if you ever see just the word speed, it's just the absolute value of velocity. So just be careful about that. Speed is just the absolute value of velocity, whether going forward or backwards. Is speed increasing or decreasing? That's almost like the derivative of speed, right? This change of speed. And we define that as speed is increasing when both velocity and acceleration have the same sign, and decreasing if they're opposites of each other. Okay. And then D, find the position of Q the first time it changes direction. Okay. So Q, the first time it changes directions, we said, when the first 0 was at 3. So that's when it first changed direction. So we're going to try to figure out from the integral from 0 to 3, that's how much change happened of the equation t squared minus 8t plus 15 dt. And then we're going to add our initial Q. So was it
Wait,
X?
3? How did you know it was 3?
Our first, okay, so this is when it first changes direction. And looking at my graph here, we said it first changes directions at 3.
Oh, just change
T is equal to 3. Yeah, when it changes sign.
Okay. Continue.
And we also want to make sure we add our initial, right? Where we were at 0, x of 0 for Q. And I think they did tell us this. They told us at Q, our position at 0 is 5. So 5 here is equal to, we take the integral as, sorry, that's a plus sign, t cubed minus 8t squared over 2 plus 15t. We plug 0 and 3. If we plug in 0, that's all going to be 0, so we just have to worry about the 3 on top. 5 plus 27 minus, that's a 4 times 9, plus 15 times 3 is 45. And know what? You can just leave it like that. Okay. Oops. T cubed, oh, thank you. Thank you. T cubed over 3. Okay. So I would say like none of these questions have been that tricky. The problem is that they are asking a lot of information that we did cover in first semester, and a lot of little nuanced things. Like when it came to speed of a particle increasing or decreasing, making sure you knew the relationship between acceleration, position, and velocity. Also the idea of changing directions. We haven't done that in a while. So, okay. Okay, the velocity of particle P moving along the x-axis is given by the differentiable equation v of t. So here's v of t, that's the velocity of particle P, okay? Where the velocity is measured in meters per hour and t is measured in hours. Select the values of velocity are shown on the table. Particle P is starting at t is equal to 0. Acceleration at particle t at t is equal to 1 is known to be this. Okay, maybe some values. Also, continuous function f is defined on the closed interval from -6 to 5. 6 to 5. Okay, so this is a different function. And the figure above shows a portion of the graph f consisting of 2 line segments and a quarter of a circle centered at 5, 3. It is known that the point 3 is 3 minus square root of 5 is on the graph of f. Okay, so find the first part, find the derivative of this guy at t is equal to 1. So what's so special about those functions? They're just multiplying, right? So just do product rule. This big idea is take the derivative. F prime of t, leave v alone, t, plus v prime of t, leave f alone. We're plugging the value 1, f prime at 1, v of 1, plus v prime of 1, f prime at 1. Looking at the table, we see what v is, we see what f is. Now, what is the derivative at 1? So v prime is acceleration. Remember, v prime is acceleration. That's this guy right here. The derivative of velocity is acceleration. So we see that's -10. Sorry, I made a mistake right here. Copying it wrong. We know that v prime is the derivative here, which is the slope, rise over run, which is up 2 over 1. So it's a line. That's going to be 2. V at 1, looking back here, V at 1 was -29. And F at 1 is 1. Okay, that was like 3-4 minutes, including reading. Okay. Anyone have a question on that problem? Yeah, is okay? All right, now let's get into the damage zone, I guess. So use a trapezoid sum to find the subintervals between 0 to 0.3, 0.3 to 1, and 1 to 2.8 to approximate the value of the integral. Great. So that's trapezoid rule. That means we're just going to say base times height. So remember, trapezoid is 1/2 height, b1 plus b2. And we're just going to do that 3 times. So we're going to add up so we have to figure out which one is your b1, b2. These will be my b's, and this value here will be my height. Oops, darn it. That'll be my height, h. So my first trapezoid will be 1/2, 0.3 minus 0, and then times 0 plus 55. Just write it. Plus, so this is equal to plus 1/2, or approximately 1/2 of 1 minus 0.3. Multiply that by our 2 heights, which is 55, and then plus -29, plus 1/2 the last section, which is 2.8 minus 1 times 55, or no, sorry, -29 plus 55. Okay, done. Are you guys okay with me just reading the question? Not tricky?
So would you just leave it like that on the test?
The rest is arithmetic, and my answer would be yeah. Because if you actually
You should
did
just
it,
do that to save time then.
yeah. Like if you look at the other one, I didn't even multiply that out. Well, this math is wrong here. I should put parentheses. But yeah, that would save you time. Yeah, as long as everything is numeric. Mm-hmm. Okay. The arithmetic part, they don't care. 1 plus 1 is, they don't care. Okay. Let's see. Next one. If, okay, C. If the integral between negative 6 and 5 is 7. So the problem is, looking at the graph, they didn't give us what negative 6 was, right? They didn't give us that part. That's why I was a little confused there. Okay. But negative 6 to 5 is 7. So the whole thing is 7. Find the value from negative 6 to 2. Show that the work that leads to your answer. Okay. So the goal here is for you to realize that you can break up this integral from negative 6 to 5 of f of t dt is equal to negative 6 to negative 2 of f of t dt plus the integral from negative 2 to 5 f of t dt. Being able to separate the integral. Right, me working from negative 6 to 5 is the same as me breaking up in two shifts from negative 6 to 2, negative 2, and from negative 2 to 5. We know that this is 7 here. That 7 is equal to some integral negative 6 to negative 2, f of t dt. That's what they want us to find. And then plus, we have to figure out what this is. So let's go up here and start tagging some values. This is a triangle 1 by 1. That's a plus 1. So it's going to be 0.5 because 1 times 1, 1/2 base times height, 0.5. This here is going to be a negative 0.5. Okay, that's going to cancel them out. This here, you can actually take that as all negative. So you could break up this into a couple triangles. Let me just do that instead. Let's do blues, blues, and that's going to be reds. This is red over here, and this is all blue. Okay. Okay. So let's write that out. So that integral from negative 2 to 5 of f of t dt is going to be a triangle which is 1/2 base plus height. Sorry, base times height. Darn it, come on. Times height minus, that's going to be 1/2 because it's a triangle. The base is 1.5 by the height is 1. We're going to plus the next triangle, which is base is 1.5, 1/2, 1.5 times the height of 3. The last part is a circle. We're going to add a circle minus, we're going to take the square minus the circle. So the square is 3 by 3. Yeah, 3 by 3. So it's going to be 3 times 3 minus the circle, which is pi 1/4 pi r squared, which is that. Okay. So I guess you can write that together. So yeah, that looks really messy. But the final part to this is then you have to move this over, right, to solve for it. So this would be, or actually move this over to the left. So the final answer would be this answer, or 7 minus this answer here. Did I skip too many steps? Are you guys okay with these parts up here? Are you guys okay with these parts over here? Anyone have a question on how I got these parts? We're good? Inbar, you're good? Okay. Olivia? Okay. Anyone else? I only see 4 people, so. And Charles and Andrew did this already. Okay. Let's do the next part. The last part, let me go ahead and let me just save that to photos. I'm gonna run out of space. I don't know why I couldn't download it. It's probably because it's Google Docs. Okay. The next portion here is evaluate this integral from 3 to 5 and 2f prime t plus 4. So I'm thinking this could be separated. So this could be separated to be the integral from 3 to 5, bring out the 2, f prime of t dt, plus the integral of 4, which is a constant, dt, from 3 to 5. So the right side, we would just do the integral. This would be 4 t, plug in 3 to 5. So it'd be 4 times 5 minus 3. The left side, what is the, do we have, we don't have that integral. So this would be, looking at our rule, the integral of f prime is f. This is 2 of f, f of 5 minus f at 3. Looking at the graph, we were asked to look up what 5 and 3 are. And I need to look back at the graph, which I didn't save. Let's see if I can get there. Save 2 photos. F at 5 was 0. F at 3 was given to us. Remember, they told us that's going to be 3 minus square root of 5. So they gave us those values. Okay. Are you guys okay with how I did D? Let me pull it up again.
Is that Peppa Pig thing for your kids?
It was free, so I figured I'd download it. But then my kids, they rather watch videos right now. So I just play it while no one's around.
Oh, it's your chill time?
I'm just kidding. It's terrible. No, I don't play it. So we said f of 5 was 0. Oh, come on. Okay. We said f of 5 was 0. And then f of 3, they told us, was 3 minus like square root of something. Oh, it's right there. Square root of 5. I can see it. 2. What's that?
These all feel like relatively simple and I think easier to understand than the ones that we were doing in the FRQ sets. Like I feel like they're worded clearly.
They seem to be more straightforward.
Yeah,
Like,
I don't think you had. Yeah, I didn't think you had to do them. I was just saying people should do it in the timed thing, since it's 7 parts.
Good point.
To show you guys. That was not.
Yeah. But no, Charles, I think you have a good point, is that you have to be able to cram all these questions within that 45-minute period.
No, it wasn't a matter of these are hard. It was just do it under the timed thing. Because like, yeah, we've been doing all this stuff. Like, it's just more, it wasn't of like, oh, go over them because they're complicated. It was more just everyone should just do it under the time and see how far they get through and if they get them right.
Okay, that's a good point. I think if you guys do a couple other FRQs and come back and do this one and time yourself, that would be a good way to test yourself. That same thing for the SATs. When you guys practice SATs, like you do practice when you're being timed, so you know what 20 minutes is like. So you're right. 25 minutes for this test is going to go really fast. Okay. Were there any tricky parts to these that you felt like it was going to be difficult? No.
I feel like there were some trickier explanation parts on the second problem, but
I feel like Andrew's not going to give you a genuine or
no, I'm like they ask you to explain how the squeeze theorem or L'Hopital's rule like work in the context. So I feel like that would be a little harder to do because you have to actually write it out in words.
I mean, I also saw that you're allowed to like use your textbook on the test, right?
Yeah, but remember how you're limited to the amount of time that you have? So just like any test, when they say open book, they're not planning for you to finish if you open that book.
Searching through a textbook is like 20 times longer than like searching through a notebook.
I feel like if you really like aren't sure what something is, you can just look it up really quickly, and that's not going to take too much time.
To do it.
Just Google it.
Yeah,
Like,
just Google the rule really quickly and then use it.
There you go.
If you
Perfect.
forget like what intermediate value theorem is or something like that, you can just look that up and have it on.
It's true, right? Because intermediate value theorem, once you see that formula, you know it. You're good. Not encouraging you to cheat or anything, but
they said you can use Google. So.
Oh, they did?
Yeah, because
how about use the Asian guy on the other side of LA?
We tried asking that guy.
I know that wasn't going to happen.
He was being a pain in the ass and wouldn't do it.
Oh gosh, that guy.
Apparently, there was a spike in Google searches in certain terms related to the FRQs that were for AP Gov today. So a lot of people are using Google.
That is perfect.
Yeah, I'm not gonna deny or say I didn't look it up. But let's just say I looked up like 2 letters and the question was already there.
Do you think like that's really gonna help? Like, do you think it helped you? I mean, not
I think
you.
it's also a bit different for Gov compared to like calculus.
Yeah, but you guys are right. Like, if you need to look up a formula or something, searching it really quickly would be helpful, right? And if you, that's a, like, we're able to get the other problems out pretty quickly, and you do have some extra time, like it will be helpful.
Yeah, I mean, yeah, we should have been more clear that you didn't have to like go over these, but it was just more like.
We don't need to write out the question or anything like that, right? We just start.
You have to show the work that leads to your conclusion. But no, you don't have to write like, oh, you should write out any variables you decide to use, right? If you're going to call something F, you got to make sure they understand what F is. So if you're going to relabel anything, or you want to make sure you highlight any of the formulas that you're going to plug in, make sure you do that.
I have a general question for this test, like, because you know how we've been like leaving a lot of answers without doing the arithmetic part of it.
Yeah.
When there's ones that it's like that, and then it says indicate units of measure, how does do you just have to like quickly can you still leave that without solving and then just write like feet per second next to it
at the very end? Yeah. If you want to draw big parentheses and say meters over second.
Okay. Like
if they ask you something for velocity, you know it's going to be, or some type of rate, it's always over time. So for sure that's true. If they say something like area, we know that's units squared already. So you can just write that.
Also, do you have to give your answer in some sort of like sentence? Because looking at the answer guides of all the previous ones, the answer was always like the velocity of P is this, rather than just like.
So you just want to make sure you're answering the question. Like on a problem that we did before, they asked when is it increasing, and if you just increase, if you just write T is between 5 and 6, that's not really answering the question. You have to like say, oh, it is increasing between 5 and 6. And what's increasing? Well, F is increasing between 5 and 6. Right? So just be clear and concise with your answers and make sure you are answering the question.
When we're using units in the answers, how come sometimes like in the denominator, like the denominator is squared? Like it could be like I don't know, something over like times squared. How would we
That's
So, sorry, what?
I was gonna answer, but you.
Oh, go ahead, Charles.
Well, like usually it's if it's like an area problem, if you're multiplying two things times each other, one of them, like if it was like feet per hour times hour, then it's going to be feet per hour squared in the units.
Okay, thank you.
So just make sure when you're writing it out, like sometimes writing out the units is helpful. If I say meters, 5 meters per second, and then they say divide that by 4 seconds or something, this will be 5/4 meters per second squared. Like by writing out, you can see the units. Oftentimes we don't write out the units because it saves us time. But maybe if it is a units question, you might want to write it out.
If they ask you to include units, do you have to include it in your work, or can you just put them in your answer?
I don't feel like you have to include it in that like general work section, but maybe at the very end for the last units, just so that they see where you got the units from, just to cover your bases.
I mean, if we just put it in like the initial like setup and then just at the very end, that should be fine, right?
Yeah. Mm-hmm. Anyone else have any other questions, or you guys need me to cover any other free response type questions?
Yeah, I have a FRQ question.
Sure, shoot.
So the year 2016, question 1, part C.
Okay. Use your answer in part B to estimate, to find the estimate of the total amount of water in the tank to the nearest. So question 1, be aware that question 1 normally is a calculator question, and I think, oh, okay, never mind, I think. Use Riemann sums, the 4 subintervals, to find the amount of water that was removed from the tank. And then, is this
Yeah.
overestimate, underestimate? And then part B was?
The answer is 8,050. If you're going to do C, you need the answer.
Oh, what was the answer?
8,050. 8050.
Okay. So that was our Riemann sums. Now use the answer to estimate the total amount of water in the tank to the nearest liter at the end of 8 hours. So this part is the value that's being pumped in. And then we are going to take out the water that's being, this is being removed. So we just have to subtract them from each other. Okay. So being pumped in, so we take the integral of 2000 e to the negative t squared over 20 between 0 and 8. So that's how much water that was pumped in. And then we want to subtract out the water that was being lost, which is 8,050. And then don't forget that at the time 0, there was already 50,000 liters in the tank. So that's 50,000 liters here. So go 50, which is our initial. We pump in this integral value, and we subtract out water that we lost. Taylor, are you okay with those 3 parts?
Yeah, I didn't see the 50,000 liters in the question. So
and that's a thing. There's always a starting value. Like if we're changing, adding, and subtracting, there's always a starting value. So make sure you find that.
Got it.
Okay. Anyone else have any other questions that we can go over?
I mean, I have questions. I feel like at this point, like there's no.
I mean, there's still some time just to look at other types of questions that you might not have seen just for review. Like like stuff like L'Hopital's rule. You haven't seen L'Hopital's rule in like forever. So unless someone didn't bring it up today, you might have forgot to review it really quickly. And I think that's our biggest thing. Just doing some more problems, just so I say, okay, I've seen that before. Oh, I remember the trick to that. And all these problems have these tricks, like just reading it and saying, okay, I gotta do this or gotta do that. So, okay, anything else I can help you guys out with? You're tested at 10 o'clock tomorrow, right?
11.
11? Okay. And then everyone has tried to access those AP practice tests so that you know how to submit and stuff? Has all tried that already? Okay, good.
I actually have a question.
Invar, which one do you want to review? Oh, optimization. Do we have an optimization here? I don't think so, right? I don't have an optimization on me. I might have one in one of my folders.
They haven't done an optimization problem in a very long time, so I don't know if that means that they're more likely to do it or less likely to do it. So.
Okay, all optimization is, you just gotta be aware, it's just take the derivative. Like even this, we have an enclosed rectangle with a fence, right? Reading the example 1, we have 500 feet of fencing material and a building on one side of the field, so you don't need any fence. Determine the dimensions of the field that would close the largest area. I'm just gonna click on this guy's solution. He drew the picture, draw the picture. Here's our equation that we want to maximize. All optimization questions have optimize this. That's the equation you take the derivative of. So they want to optimize area. Write the equation for area and then take the derivative of it. Okay? And then, but you might want to say, I don't want to take a derivative of x and y. So let me go ahead and real quick, darn it. Everything has to be done so slowly. If not, it doesn't know you want it. Okay, so this problem, we said the fence adds up to 500. X plus y equals to 500. We have 2 of them, 2x plus 2y. And then area is equal to x times y. So all optimization questions always say optimize this. Optimize area, just take the derivative of area. But you don't want to take the derivative of area with x and y. So they always give you a secondary equation where we can solve for that other variable. So let's solve for y. This will be 2y equals to 500 minus 2x divided by 2. Y is equal to 250 minus x. And plug it in. So a is equal to x times 250 minus x. Optimization, just take the derivative of that. I'm going to multiply it. It'll be negative x squared minus, sorry, plus 250x. So when I take the derivative, it'll be really fast. It'll be 2x. Is it 2x? No. Oh, just forgot that. Plus 250. Now, critical points, right? Critical points. When will this be a maximum? So we take the derivative and make it equal to 0. Optimization, take the derivative, make it to 0. Moving stuff over to solve for x. Negative 2x equals to negative 250 divided by x, divided by negative 2 would be a positive 125. So we know for sure x is 125. And when they ask you dimensions, they give x. Now you go ahead and plug it in and find y. So y is equal to 225 minus, sorry, 250.
Wait.
125. Did I mess up?
Mr. Ko?
Yeah.
Did you use that 2x plus 2y equals 500 as the initial equation for optimization?
Oh, no, I messed up here. You're right.
Yeah.
I'm going to change one of the variables. That's just because I was rushing. Because one of the variables said that one of the sides was a building. So I'm going to just erase the 2 there.
Yeah, they wouldn't give us one word like that because you'd know it's a square immediately. So.
Yeah, good point. But there'll be some conditions. There's always some like stupid conditions. There'll be a 2. Sorry, I got to change this around. Then that's going to be 500. Well, anyways, you get the idea. Okay, you get the idea. Yeah, everyone gets the idea. minus will be 2 in front. Okay, that'll be 4, be 500. Anyways, whatever, you get the idea. Okay, optimization. Always just take the derivative of whatever they want you to optimize. Okay, that's optimization. No, that's not it. I remember I was in grad school at Cal State LA, and I took a class called optimization. I took a freaking class called optimization. And the whole quarter, all you had to do was take the derivative and set it to 0. That was the whole class. Okay, that's it.
Bro, what
The professor
college-
went around and asked Charles, what do you do in this problem? And you would have to say, you take the derivative and equal 0. That was it. It was terrible.
Didn't you go to UCLA or
I
something?
did, but then after you graduate from 4-year school, you're like, what should I do next? And you figure there's no jobs, so you go to grad school. And that's how I met Mr. Campos, and Mr. Campos got me a job here at Hamilton.
Wait, but this optimization was in grad school or UCLA?
No, this was in grad school.
Oh, okay. I thought that was like your UCLA math class, and I was
No,
like,
they didn't have that. In UCLA, there's a programming class where you would have to write code to optimize something. You'd use like derivatives to optimize. Yeah, the Andrews thumbs up there. But yeah, it's kind of cool. Like you would write the slope, and the slope would get you closer, and then you take the next derivative, gives you the next slope that's closer. And a computer could do that like a million times. You get a pretty good, accurate approximation. Inbar, are you still here? Are you okay with this idea of optimization? It's just always, if you look at all these practice problems, they're all like this, where they say, like, find the maximum, right? So let x and y be 2 positive numbers, and then find the maximum. So we're going to somehow take the derivative of that. So these are pause notes. There's always like easy examples here.
Yeah, I'll look up more practice problems later today and make sure I get it.
Yeah, I want to
I just
spend
have
too
a
much
technical
time.
question.
Yes, go ahead.
Are you going to be reading the responses for Miss Yagi's class?
What responses?
Teachers are supposed to be able to review their kids' like tests
What?
you
to
have to
check
review, you have to review and
um,
make sure we didn't plagiarize.
to
Yeah,
make
you
sure
have
we
to
didn't
report.
plagiarize and it looks like our own work.
You have to
I don't
report
know.
me when I cheat.
So you got like 4 times the fucking amount of reviewing you got to do, Go.
I don't know. Are you grading ours? Or
Okay, when
not
I-
grading, but like
I'm told
reviewing,
about
and
that.
then you're supposed to flag us if you
Are you
think there's
reviewing
plagiarism or
ours?
something.
Like you guys.
Yeah, you have to do hours. I know that because that's
Okay.
the whole thing.
I'll be
So
surprised. Yeah, you're all cheats. Yeah, all from Google.
you better
But
let us all pass, bro.
Be 30.
I'll start editing it. Like, oh, he meant to add a plus sign there. Yeah. I haven't heard about that. I guess they'll be emailing me to do that. But I guess this is like a great time to be nice to your AP Calc teacher, right?
Mr. Ko,
Yes.
can you possibly go over like a quick L'Hopital or whatever problem? Because I never learned that.
Okay, so L'Hopital's rule, the biggest deal you can see here is that if I ask you the limit of something stupid, of limit as x approaches 0 of x squared plus x over 3x squared plus 4x, something like this, okay? Now, if I plug in 0 to the problem, we end up with 0 over 0. So if you remember for limits, always just try plugging it in and see what happens. You should always plug it in. Now, when I plug it in, we end up with 0 over 0. Screwed, doesn't work. So all we have to do is just take the derivative and try again. The derivative of x squared plus x is 2x plus 1. And the derivative on the bottom is 6x plus 4. Okay, and then plug it in again. Oops, 1 over 4, that's your answer. So all L'Hopital's rule says is that if it doesn't work with 0 over 0 or infinity over infinity, take the derivative, try again. Don't take the derivative like a division problem. Take a derivative of them separately. Super easy. Take a derivative of them separately. Okay. Now, the same question could have been done if we look at us going to infinity. If this was going to infinity. So if I plug in infinity and infinity, this would be infinity over infinity, which doesn't work either. So same idea, you plug in, so you take the derivative, and now we're here. And then if I plug infinity here, it still doesn't work. This would still be infinity over infinity, right? So go ahead and take the derivative again. Fine. 2 over 6. The limit as x approaches infinity is 2 over 6, which is 1/3. And that answer works for me. Now,
So
what?
say if you had something like x to the 8th over 3x to the 8th, can you just keep doing L'Hopital's rule like
Yes.
seven times?
Yes.
Okay.
But if you remember from pre-calc, let's put +1 here. Remember from pre-calc, this is just a horizontal asymptote, which is 1 over 3. So you could have done horizontal asymptote, or you could have done L'Hopital's rule. Okay. What is not L'Hopital's rule? If it's 0 over 5, that is not L'Hopital's rule. If it's 5 over 0, not L'Hopital's rule. Only time L'Hopital's rule works, 0 over 0 or infinity over infinity. And then let's just take the derivative. Try again. Oh, Taylor, your lights are on. You okay? Okay, any other questions?
Are there like any times we like have to use limits when it doesn't ask us to? Like what type of question would that be? Do you get what I'm saying?
Yes. It's when they give you a question that really is a derivative. Like remember how they'll ask you limit as h approaches 0 of f of something x plus h minus f of x over h?
Mm-hmm.
Maybe they'll give you a question that looks like that. And they'll say, okay, what is the limit when this is actually just f prime? Just take the derivative instead. And this was oftentimes seen in multiple choice tests. So whether you'll see it in a free response, I don't know. Usually they'll give this in a multiple choice test, and you'll be like, what the hell? And you realize, oh, let's just take the derivative.
I meant more like, are they ever going to give us a question like in word form, like, is this continuous or something? And then we have to use limits. Like, are there any keywords to look for? And then we're like, okay.
There's actually something like that, I believe, on the second set of questions, where you have to figure out that since they told you it's differentiable, it's continuous as well. And then you have to like use the squeeze theorem to prove that something else is also continuous. So yeah, you should check that out.
The squeeze theorem is terrible. Like the only time I use squeeze theorem is like that 1 over x rule, something like that, or sine, like x over x was it? Okay, so that's the only time I ever use it. Okay, anything else I can help you guys out with?
I have another question.
Yeah, sure.
Could you review slope fields?
Okay, all slope fields are, I keep saying that all they are, dx. Let's say this is equal to x over y. And I'm going to give you a couple points. I'll call this x squared, okay? And we'll do 1, 2, 3, and do 1, 2, 3, okay? So all you do is just draw a tiny little line that looks like the slope of a line. So at the point here, call that 1, 1. So when I plug in 1, 1 here, that's just 1 over 1. The slope is 1 over 1. Rise and run, 1 over 1. So it looks like a 1 over 1. It doesn't look like this. It doesn't look like it's too sharp. It's not going the negative direction because it's slope 1 over 1. 1 up, over to the right 1. Let's look at x of 0. This is 0, 1. So I plug in 0 and I plug in 1. So that's going to be 0, flat. On my left side, negative 1, 1. So that becomes negative 1 here. Squared becomes a positive 1. And the y value is positive 1. We have a 1 over 1. Now, are they going to judge you if you're off like by 0.1? No, they're not. It has to look pretty close. That's it. And they'll compare that slope to other slopes. So for instance, if I give you the slope is 2 versus the slope is 1. So this one would look like up 1 over 1. This one will be up 2 over 1. And you can see, obviously, like one is more slopey than the other. Right? Or if you give me a negative slope, you just have to make sure it's going down. Let's look at this over here. This is negative 1 over, negative 1, negative 1. So this would be negative 1 squared is positive 1 over negative 1. So that's going to be down here. And look at that. Negative slope, negative 1 over 1. On the right, 1 comma negative 1. Same idea, it's going to be the same slope. And that's going to be 0.
Do you think they'd actually give us slope field though, since it's an FRQ? Like, because we'd have to draw it ourselves, right?
But how are you supposed to show them your work anyways? You're supposed to write it out on a sheet of paper, right? So I don't know. Theoretically, they could just show you a picture and say, draw the slope field for these 6 points. And you would just draw what I drew.
Yeah, that's true.
So, and I would say, please give me slope field. That's like easy problem.
No, it is easy, but I'm just saying I don't think they'd even trust us to like draw straight lines.
Oh.
Yeah, they wouldn't, like, slope fields are like interpretive. They're not necessarily.
Also, can you imagine like however many people take this test, like drawing little lines? They're all going to look different.
On the AP exam, really all they do is they do this. That's it. That's the graph. And then you actually draw on the test like your field, like that. You just draw this. So I feel like even on the free response test, on the real AP, the normal AP, they just draw like 6 dots and they say fill in those 6 dots. And it is interpretive. And as long as like the slope of 2 looks different than the slope of 1, they'll give it to you. But when the slopes look negative, they'll give it to you. Okay. But when you draw a slope of 0, if it looks like that, that's not a slope of 0. Okay. Yeah. All right. Inbar, was that good?
Yeah, thanks.
Okay. Cool. Anyone else? Okay. All right. I'll call it then. Besides trash talking everyone.
This is going to be